Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 6. A transparent container contains layers of three immiscible transparent liquids of different refractive indices. A laser beam is pointed at the layer 1 as shown in the figure at an angle theta 1, and we need to find out the minimum value of this angle theta 1 that will ensure that laser beam does not enter region 3 at all. So we can see that ray is moving from denser medium to rarer medium. So each time when it is moving from 1 to second, it is moving from denser to rarer. Again, from second to third, it is moving from denser to rarer. So it will move away from normal. And we want that it should not reach the layer third. So what I can do is, I can draw something like this. So this is the ray that it crosses medium 1 and 2 and reaches layer 3. And here, either it should follow TIR or it should graze along the surface. So the minimum angle that will ensure that it will graze along the surface, it is when this angle, that is angle of refraction for medium 3, will be 90. So that's what we can do. So I can write it as theta 2. Fine. So applying the Snell's law, let's try to find out the Snell's law here. All right. And if this angle is theta 2, this will also be theta 2. Alternate interior angles. So let's apply Snell's law. Snell's law for media 1 and 2. What I can write? N sine theta 1, that is equal to n by 3 sine theta 2. So mu 1 sine theta I, it is equal to mu 2 sine theta r. Here I is theta 1 and r is theta 2. Now again we can apply the Snell's law at this interface for media second and third. Again applying Snell's law. What we can write? N by 3 sine theta 2, that is equal to n by 5 sine 90. Here angle of incidence is theta by 2 and angle of refraction is 90, because we want that ray should not enter media 3. So from equation 1 and 2, I can write from 1 and 2 n sine theta 1, it is equal to n by 5 sine 90. So you can see that n sine theta 1, it is equal to n by 3 sine theta 2, and n by 3 sine theta 2, it is equal to n by 5 sine 90. So this gives us this thing that n sine theta 1, it is equal to n by 5 sine 90. Sine 90 is 1. So I can write sine n sine theta 1, that is equal to n by 5. So n gets cancelled out with this n, and I am left with sine theta 1 is equal to 1 by 5. And if I take the inverse of this, this can give me theta 1. So theta 1, it is equal to sine inverse of 1 by 5. So this is the required answer. So this theta 1, it should be, minimum value of this should be sine inverse of 1 by 5. And it is approximately 11.5 degrees. So even if you leave it at this, you will be getting the full marks. So this is the required answer. Keep learning, keep practicing, keep excelling.